Alright, in this lesson, we will graph not only the original logarithmic functions, but we will also graph their inverses on the same plane so we can see how the two graphs compare to each other. And we're going to use some shortcuts that will allow us to graph the inverse without actually finding the inverse. So that'll be nice. So first of all, let's go ahead and graph this log function. So remember, when we graph logs, we start with the y values. So we use -2, -1, 0, 1, and 2. Now to get the x values, it would be useful to rewrite this in in exponent form. So starting with the base, so there's my 3. Now this x and y will change sides of the equation. So this x is going to come over here and be x equals, and the y is going to become the exponent. So we have x equals 3 to the y power, and I'm going to use that over here. So x equals 3 to the y power means I'm going to have 3 to the -2 power, and 3 to the -1 power, and 3 to the 0, and 3 to the 1, and 3 to the 2. So that is going to give me 1/9 and 1/3 and 1 and 3 and 9. Now there is no a value, so we can forget about this column. And there's also no shifting. There's nothing being added or subtracted. So these are going to be the actual values, not just the temporary values. So here we go. So 1/9 is just barely over at all, basically on the line. And then a -2 will be right here. And then 1/3 and -1, so it's over just a little bit and down 1. And then 1, 0, and 3, 1, and 9, 2. So we have these values to guide us. And of course the asymptote, because there was no shifting, will be the y-axis. So there's the asymptote, make sure you draw it. And then we will draw the curve as best we can. So down here it's going to basically trace the asymptote until it gets to here and begins to curve its way out. Alright, please make sure you draw your graph all the way to the edges of the grid. Alright, so that's the original function. Now we are supposed to graph the inverse. Now rather than finding the inverse function, which we could do and making another table of values, what we can do instead is just realize that the inverse function will be involve these same points, just reversing the x's and y's. So for example, and I'm just going to show this one example here, instead of 1/9, comma -2, this would become -2, comma 1/9. Alright, just reverse the x's and y's. So if we do that, and I'll have to see if this is going to get in the way, but so we'd have -2, comma 1/9. So that would be left 2, and then up basically nothing. Alright, 1/9 is so small. And then this one, okay, we can do it mentally. It'll be -1, comma 1/3. Just in your mind, reverse it. So that would be -1, and then up just a little bit. And then 0, comma 1, alright, just reverse it. So 0, 1 would be right here. And then 1, comma 3 would be here. And then 2, comma 9. So 2, and then up 9 would be right here. So you can see what's happening. Also, remember that the inverse of a log function is an exponential function, and they have horizontal asymptotes. Okay, so this would be the asymptote for the inverse function. So now let's go ahead and graph this inverse function using the points that we made. On this side, it will appear to trace the asymptote, even though we know it doesn't actually touch. And so there you go. Now, please notice the relationship between these two graphs. If you imagine a diagonal line from one corner of this graph to the other. By the way, this is the line y equals x. Okay? Now the line y equals x should be like a mirror between the original function and the inverse function. And this is true for any function and its inverse, not just logarithmic functions and exponential functions. But if you're doing it right, just sort of as a mental check, ask yourself, are your two graphs mirror images of each other over this diagonal line called y equals x? Alright, on to number 2. I should have mentioned this earlier. If you have a pencil in your hand, put it down. Watch the video. Obviously, if you're watching this, it's because you needed some help. Watch me do it, see how I do it, learn how to do it, but then get the practice of going back and doing it yourself without looking. Otherwise, you'll get a false sense of thinking you know what you're doing when you really don't. Okay, because this is a log function, we will start with the y values, -2, -1, 0, 1, and 2. There is no a value still, so we can forget about this column. Now, to get the x values, it would be helpful to rewrite this in exponent form. So, start with the base. So the base is 1/2. So, reversing the sides of the x and the y, I will have x equals 1/2 to the y power. So that's what I'm going to use to get these. So that means I'm doing 1/2 to the -2 power, 1/2 to the -1 power, 1/2 to the 0 power, 1/2 to the 1 power, and 1/2 to the 2 power. So, and this is how I will get my x value, because x equals all of this. Now, when I do a negative exponent, one word, reciprocal. So this is going to become 2 to the +2 power. All right, reciprocal and make it positive. So that's why this is going to be 4. All right, reciprocal here and a +1 power would be 2. Anything to the 0 power is 1. All right, obviously 1/2 to the 1 power is 1/2. And 1/2 squared is 1/4. So these are the values I'm going to graph. Now these will be the actual values, not temporary values, because this equation has no shifting, no translation. Okay, there's nothing being added or subtracted here. So I will graph it in blue because I know it's my final answer. So 4, -2. So it's over 4 down 2. Then 2, -1, 1, 0, 1/2, 1. So over half a square, excuse me, and up 1. 1/4, 2. So over just a little bit and up 2. Right about there. So we can use these 5 values to draw our curve. Don't forget the asymptote, which is still at the y-axis. Make sure you draw that asymptote. Now draw your curve as best you can. So clearly it's approaching the asymptote like this. So on this end, it's going to appear to trace this asymptote till it gets down to here and starts to peel away. Okay, so something like that. Please make sure your graph goes all the way to the edge of the grid. So there's your original. Now let's go ahead and do the inverse. Remember, the inverse we can get by simply reversing these x's and y's. So instead of 4, -2, we would graph -2, 4, for example. Okay, so -2, 4 would be here. The rest of these we can just do mentally. We don't have to write them down. If I reverse these, then this would be -1, 2. So left 1, up 2. This would be 0, 1, which would be right here. This would be 1, 1/2. So over 1 and up 1/2. This would be 2, 1/4. So over 2 up just a little bit. Just a little bit. So these are the 5 values. Now this is exponential now, so this will be a horizontal asymptote. I'm blanking out there, a little brain freeze. Alright, so there's your asymptote. And let's draw this curve as best we can. Alright, so over here it's going to appear to trace this asymptote. Okay. Okay, so your graph should look something like that. Once again, notice that if you imagine a diagonal line, the line y equals x, these two, the double image of these two graphs are like mirror images of each other. See how this green line splits this double image right down the middle? Like if you look at the blue and the red and the blue and the red over here, they are identical. Okay, like this red part matches this blue and this red part matches this blue. Alright, together they're mirror images. You get it. Moving on. Aw shucks, number 3 is going to be next level. We have an A value to deal with this time, and we have a little shift going on. Alright, but what we do first is we ignore the A value and any shifting translations and just look at the parent function. So once again, it's helpful. Well, first of all, log function. Once again, we start with -2, -1, 0, 1, 2 on the y values. And for the x values, it would be helpful to write this in exponent form. Starting with the base gives us 3. And the x and the y sort of switch sides. So this gives us x equals 3 to the y power. And this is the form that we'll use to find the x's. So, of course, that means we are doing, like we did before, 3 to the -2 power, 3 to the -1 power, 3 to the 0 power, 3 to the 1 power, and 3 to the 2 power. Okay, so once again, this is going to be 1/9 and 1/3 and 1 and 3 and 9. Now I'm doing these in green because these will not be the final points, because I still have to, I'm going to have to shift later. Okay, yes, doing it in green. Now, it's time for the AY though. We need new Y values. And we will get them by looking at the A value of 4. So because the A value is 4, that means I'm going to take these Y values and I'm going to do times 4 to them. Okay, so that's going to give me -8, yeah, and -4, and 0, and 4, and 8. I just multiplied everything by 4. Now, since we did that, we can forget about the old y values. So we'll just be graphing these green points right now. Now these points are still temporary because of the shift that I have covered up. But let's do this for now. So we have 1/9 and -8. So that's, alright, we need a little more space then. Okay, so 1/9 is just a little bit over, and -8 is right here. 1/9 is so small, it's virtually on the y-axis. Okay, and then we have a 1/3 and -4. So that's over a little bit, but it's at -4. So that'll be right about here. Then we have 1, 0, and we have 3, 4. Okay, and then we have 9, 8. Big numbers. So here's 9, 8. Now I will not, repeat, will not draw the curve through these because these are temporary points. Now let's talk about the shift that is about to occur. All right, I covered it up, but this shifting, what is it? Say it out loud right now. Hopefully you just said, that is down 2, Mr. Burton. Please notice this is not in parentheses. It makes a difference. If this were in parentheses, then this would be right 2. All right, because it'd be on the inside. But without parentheses, it's more like this. Okay, this -2 is on the outside, so that's an up-down number. This is a down 2 situation. So I'm going to take each of these green points and move them down 2. And these will be my final points, so I will graph them in blue. So down 2, down 2, down 2, down 2, and down 2. So these blue points are the real deal. Now, shifting everything down 2 does not change the asymptote. All right, the asymptote was the y-axis. Moving a vertical line up and down doesn't change anything. All right, so the asymptote is still going to be the y-axis. So now we will draw the curve as best we can. This bottom part of the curve is going to appear to trace the asymptote for a little while. Alright, so it should look very much like that. Please make sure your graph goes all the way to the edge of the grid. Okay, so we graphed the original. Now we need to graph the inverse function. So remember, to graph the inverse function, all we have to do is reverse these. And I'm just going to do it mentally, if that's okay with you. Now, remember, this is without any shifting. So, I'm going to graph these in pink because these are temporary. These are not the final answers. But if I reverse these, that would be -8, 1/9. So that would be left 8 and down, and up 1/9, which is so small that it appears to be on the line. Then I'd have, if these were backwards, all right, because I'm doing the inverse now, so it would be -4, 1/3 if we switched these. So that would be -4, and then up 1/3 of a square, which would be about there. And then it'd be 0, 1 if these were backwards, and then 4, 3 if these were backwards, and then 8, 9. Which should be right there. Alright, again, I am not going to draw a curve through these because I have not shifted these yet. Now, here's the trickiest part of this process. Understanding how the shift changes. Let me give you a little overview first. Take a look at this empty graph. Okay, this is the x-axis, and clearly over here, this is the positive side of the x-axis, and this is the negative side of the x-axis. Alright, now this is the y-axis, and this is the positive end of the y-axis, and this is the negative end of the y-axis. Now, when we do an inverse, we've talked about the fact that what's happening is you're taking a diagonal line, and you're treating that as the mirror line, and you're flipping this, alright, over this line. Okay, that's how you do an inverse. So that means, the x's and y's trade places, but the positive x and the positive y would trade places, and the negative x and the negative y would trade places. Okay, so, now that means as these switch places, now, alright, so this positive y, this is up, okay? I'm back to talking about how things shift, like this is down 2, for example. All right, but so this is up, and this positive x value is right. okay, and this negative x value is left, and this negative y value is down. Okay, so what happens is when you do the inverse, these two switch places. Okay, so anything that was up becomes right. Okay, and anything that was left becomes down. These switch places. So up becomes right and left becomes down. In other words, the two things that were positive, all right, the two positives switch places. Up and right, those are both positive. They switch places. Left and down, they were both negative. And the two negative things switch places. Okay? So left and right, left becomes down and down becomes left. Up becomes right and right becomes up. All right, now what in the world do I mean by that? Well, in terms of doing this problem, when I have a shift of down 2, all right, the 2 is going to stay what it is. But what did I say down was going to change to? All right, down is a negative term. All right, down is negative. What's the other term that's also a negative one? What's the other negative one? Left, okay? So if I want to do the inverse, okay, so, wait, I thought that was red. All right, so if I want to do the inverse, down 2 is going to become left 2. Okay, just one more time. Down becomes left. Left becomes down. The two negative terms change places. Anything that's up will become right, and anything that's right will become up. Okay, so anyway, the bottom line is we have plotted these temporary points here in pink. But now we have to do the shift. Because the original function was shifted down 2, the inverse function will be shifted left 2. Down becomes left. So I need to take each one of these points and shift them left 2. So this one will be here, and here, and here, and here, and here. So now these red points are the actual final graph. Of course, don't forget that we have an asymptote here. Let's go ahead and draw that. And now we'll draw our curve using the red dots, not the pink ones. Okay, so it will be very much like this. Almost missed a little bit there. Okay, make sure your graph goes all the way to the edges of the grid. And there you go. Just as a mental check, notice how a diagonal line would be a mirror between the log function and the exponent function. All right, so that should sort of help you make sure you did the right thing. Okay, number 4. All right, now we got shifting, and we have an a value, and we have a fraction for base. A lot of good stuff coming up. Here we go. It's a log function, so we start off with a -2, -1, 0, 1, and 2. Okay, good enough. Now, because this is a shift, I know this is going to be temporary, so I'm going to graph this in green. Anyway, to get the x values, start off by ignoring the a value and ignore any shifting that's happening, and rewrite this in exponent form, starting with the base. So I've got that base of 1/2, so that's 1/2 to the y power is equal to x, as these two sort of switch sides of the equation. So this is what I'm going to use to find all these x's. So please understand that that means I am doing, make it even smaller, I'm 1/2 to the y power. So that means I'm doing 1/2 to the -2 power, and 1/2 to the -1 power, 1/2 to the 0 power, 1/2 to the 1 power, and 1/2 to the 2nd power. Okay, 1/2 to the -2 power. Please remember, a negative power, you do the reciprocal. So this would be like having 2 to the +2 power. Right? Do the reciprocal and make it positive. But of course, 2 to the 2nd power is 4. If I do the reciprocal here, 2 over 1 is 2. Anything to the 0 power is 1. 1/2 to the 1 power is 1/2. 1/2 squared is 1/4. Now, I'm not going to graph these yet because I do have an a value. Okay, so I'm going to move this for a second. To get my new y values, I need to multiply by this a value. So I'm going to multiply by -3 here. Negative times negative is a positive. So that's going to give me 6 and 3 and 0 and -3 and -6. Now that we have our new y values, we can forget about the old y values. They're done. And now we can graph these green points. So 4, 6. 3, 4, 5, 6. Okay. 2, 3. 1, 0. 1/2, -3. And 1/4, -6. Alright, so we have these green dots. I will not draw the curve. These are temporary. I've done the a value, but I still haven't done the +2. Now, what sort of transformation is about to happen because of the +2? Is this going to be up 2 or right 2 or left 2? This is going to be a shift of left 2. Inside of the parentheses is your left-right motion, and it's the opposite of what you would normally think. So +2 is actually left 2. So I will just move each of these to the left 2. So I'll be here and here and here. 1, 2, and here and here. Okay, so these blue values are my actual values that I'm going to really graph. We are done. Okay, so let's put in our asymptote and draw the curve. Notice that because we had our shift of left 2, that is going to affect our asymptote, so our asymptote will also be left 2. Alright, so let's draw that curve. Starting from down here, it's going to start off appearing to trace the asymptote until it starts to branch out a little bit. Okay, so your graph should look very much like that. Please make sure your graph goes all the way to the edges of your grid. So that's the original log function. Now we can graph the inverse function simply by reversing the x's and y's. Now when I reverse these will be my temporary values, and I will still need to do the shift. Okay, so the 4 and the 6 switch places. So this will be like having 6, 4. All right, I'm mentally reversing these. So 6, 4, that would be over 6 up 4. So there's 3, there's 6, there's 2, there's 4. All right, 3, 2. Okay, so 3, 2 would be here. 0, comma 1 would be right here. -3, comma a half. So it's -3 up half. And then -6, comma 1/4 would be about here. Okay, I will not draw this curve yet. I have to shift them. So this is the trickiest part for kids to understand. If the original graph had a shift of left 2, can you guess what the shift of the inverse will be? What is that? Let me try that again. Okay, let me go normal. So the inverse. I'll give you a hint. The number part stays the same. All right, it's still going to be something 2, but left, what's that going to become? Well, left is a negative value, so it's going to change to the other negative value, which is down. All right, left becomes down. So remember, left becomes down, and up becomes right. The positives switch with each other, and the negatives switch with each other. Okay, so the inverse will shift down 2. So I'm going to take all these pink values and I'll move them down 2. So this will be here, and this one, which is like in the middle. Okay, so it'll be there, and right there, and right there, and right there. Of course, the asymptote will be down 2 as well, and horizontal. So let's draw that and draw the curve. Alright, so there's the asymptote, and now let's go ahead and do this curve. So on this end, it's going to start off appearing to trace the asymptote. Okay, so there you go. Alright, I guess I could make it even a little bit further. Okay, notice once again a diagonal line would split this double image right down the middle, this sort of a crazy fish shape. These are mirror images, and the tails are mirror images of each other along this diagonal line. And that's how you do it, people. We're geniuses today. Alright, for number 5, I'm supposed to answer all these questions for problem number 3. So we'll be looking at problem number 3. Let's start with the end behavior. Okay, so the end behavior for the original graph, alright, so this is problem number 3. The original graph is the blue, so focus your eyes on the blue. As we go to the left, we're approaching 0, okay? As x approaches, I'm not going to say negative infinity like we have many times in the past. As x approaches 0, because it's approaching the asymptote. Okay, so see if I can squeeze this in here. Okay, so as x approaches 0, alpha of x approaches. Well, as we approach the asymptote, it's going down, down, down. So that's negative infinity. Now, as we go to the right, so that's as x approaches infinity, f of x approaches. As I go to the right, this goes up, up, up into the sky. So that's going to be positive infinity. So that's my end behavior. Now, my x-intercept, okay, I mean, you know, it seems it's really going to be some decimal here. The x-intercept is about, let's say, 1.8, or 1.8 comma 0. So I'm just going to estimate. All right, now my asymptote is x equals 0. All right, my domain, that's left to right, so that's 0 to infinity. Alright, notice it's around parentheses because we don't actually touch the asymptote, not included. Now the range is bottom to top, so it goes down forever and up forever. So that's negative infinity to positive infinity. Alright, now let's switch to the inverse graph and answer the same questions. Now the inverse graph is the red, so focus your eyes on the red. Let's start with the end behavior. Alright, now as we go to the left, it goes forever to the left. So as x approaches negative infinity, we actually will say that. So as x approaches negative infinity, f of x approaches. Okay, so as we go to the left, the function approaches the asymptote. Alright, which is 0. Alright, as we go to the right, so as x approaches infinity, f of x approaches infinity. As we go to the right, it goes up forever. Alright, the y-intercept. Well, the y-intercept is like right here. It looks like about 1.8. So that's like 0, 1.8. Alright, the asymptote, of course, is y equals 0. Alright, the horizontal line, y equals 0. The domain, looking at the red, left to right is the domain. Well, it goes left forever and right forever. So that's negative infinity to positive infinity. And then the range is from bottom to top. Again, just look at the red. The bottom is 0, the top is infinity. So 0 to infinity, alright, make sure it's a round parenthesis because we don't want to include the asymptote, which we don't actually ever touch. So that is it for the front page. And I think I'm going to actually stop this video and make a separate video for the second page. Okay, but notice, before I end the video here, notice the relationship here. If you look at the end behavior, can you see how these are like backwards? Okay, f of x approaches 0, f of x approaches 0. Alright, it's like we turned this backwards. Okay, and well, switching these backwards is really the same. It's the same thing. Same thing with the x-intercept and the y-intercept. 1.8 comma 0, 0 comma 1.8. Obviously, x becomes y. Alright, notice that here with the domain and range, they just switch places. The domain becomes the range, and the range becomes the domain. So it's helpful to see the connection between these inverses. Alright, I'm going to go ahead and end the video here, and there will be a second video for the back page. Alright, for number 6, we are supposed to be looking at problem number 4 to answer this information for the original graph and the inverse. So first the original. Okay, so here's number 4 over to the right. The original, remember, was the blue. Okay, so end behavior. So as we go to the left, we are approaching the asymptote. It doesn't go to infinity. So that's why the end behavior is going to start off saying, as x approaches the asymptote, as x approaches -2. Okay, so do that, people. End behavior, as x approaches -2. The function approaches, and I believe I saw a drop down, down, down. Yeah, as we go to the left, the graph goes down, down, down. So that's negative infinity. Okay, and as x approaches infinity, all right? Meaning as we go to the right, f of x approaches, all right? And I can say the infinity this time because it does go to the right forever. So as we go to the right forever, the function goes up into the sky. So that's why we will finish this off with a positive infinity. Now, the x-intercept. The x-intercept seems to be exactly -1, 0. The asymptote was shifted to the left by 2, so x equals -2. Don't forget the x equals part. The domain is not negative infinity to positive infinity because it doesn't go to negative infinity. Domain is left to right. So left to right, the original blue graph here goes from -2 to infinity, from left to right. So the domain is -2 to infinity. We use a rounded parenthesis to show that the -2 is not included in the domain. You never reach the asymptote. That's what an asymptote is. The range, on the other hand, is -infinity to positive infinity. The range is always bottom to top. So from bottom to top, it goes from -infinity to positive infinity. Okay. What about it? So that's it for the original graph. Now I'm going to switch to red because we did the inverse graph in red. Alright, so look at the red now. First is the end behavior. This does go left forever. So when we want to say what happens on the left, we will say as x approaches -infinity. Now, as x approaches -infinity, what happens to the y values? Well, as the x value, as we go to the left, the graph approaches the asymptote. So, as x approaches -infinity, the function approaches -2. So that's the end behavior there. Alright, as x approaches -infinity, the function itself approaches -2. Think y values. The y values approach -2. Now as we go to the right, and we know it goes to the right forever, so as we go to the right forever, as x approaches positive infinity, f of x approaches. So we talked about going to the right, so this part is the up or down part. So how far does it go up or down? So as we go to the right, this graph goes up forever. So as x approaches infinity, f of x, same thing as y, approaches positive infinity as well. Why did I put a parenthesis on that? I don't know. And I don't care. Now, the y-intercept is right here, and that appears to be 0, -1. Alright, so that is going to be 0, -1. Now look at the patterns between these two. Look at the end behavior. Look at the end behavior. As x approaches -2, y approaches -infinity. As x approaches -infinity, y approaches -2. See how these are just backwards? Alright, of course switching this backwards doesn't do anything. But look at the x and y-intercept. They're the same, only they're reversed. X's become y's. Of course the asymptote, instead of being x equals -2, it'll be y equals -2, alright, because horizontal line. The domain, guess what? These two are going to wind up switching. So the domain of the inverse function is -infinity to positive infinity. And guess what? The range is going to be -2 to infinity. Now let's look at it. Domain is left-right. and you look at it, and it does go left forever, right forever. And then the range is bottom to top, so the range would be -2 to infinity. So it does make sense, but notice that the domain becomes the range, and the range becomes the domain in the inverse. So it's all about the connections. Alright, this last bit is a review, and it's a much needed review because it's one of the things that on the last quiz some of you guys did well on the front page, but then you got to this and just choked. So, do you have a pencil in your hand? Yeah, I'm looking at you, pencil girl and pencil boy. Put it down now. What have I told you? You probably had a pencil in your hand when you watched the video last time. That's why you took the quiz and you bombed the back page. Learn from your mistakes, grow. Alright, watch me do it. I'll show you how to do it. But then you will learn and reinforce by going back and doing these problems yourself. Do not copy off of me. I don't think I said that enough times. Alright, let's get our chart ready in case we need it. Okay. It came up slower than I thought it would. Let me start thinking. We need, oh, now it comes up. Great. We need to put everything in terms of 4 and 10. Is that all they give us? Yeah, okay, well that makes it easy. Everything's got to be written with 4s and 10s. So, when you look at 40, how could I write that with a 4 and a 10? I don't know, I'm completely baffled. Oh, wait a minute. 40 is 4 times 10. Bam, bam. Now I can use my properties. Alright, I'm about to use the product property, the log of a product, and split apart as addition. So this is going to become the log base 6 of 4 plus the log base 6 of 10. And we know both of these facts, so this will be 0.774 plus 1.285. You can put this in a bootleg calculator. I got 2.059er. Do not round, by the way. No rounding. Give me all my decimals, y'all. I have a cold. Can you tell in the recording? Completely stuffed up. Anyways, there's more than one way to do problem number 8. I'm looking at 100 and I'm seeing the 10 in there. Okay, one way I could do it is I could go ahead and use my quotient property right now and split this up as log minus a log. Okay, so I could do that. So I could do log base 6 of 1 minus log base 6 of 100. Okay, now 100 is 10 squared. 10 squared. So, okay, can I just go ahead and put 10 squared right now? And then I can use my power property, which says I can take this exponent and blink, put it in the front. So if I do that and pull this 2 out here, this becomes log base 6 of 1 minus 2 times log base 6 of 10. Okay, now I can use this. Well, first of all, log base 6 of 1. Okay, off to the side, I work this out. I'm hoping you just look at this and know the answer, but I know a few of you will not remember. Remember when we first learned about logs? We learned that what a log was asking, the answer to the log question is 6 to the what power is going to give me 1. This is what a log is asking you. So, well, anything to the 0 power is 1. So that means x in this case would be 0. So 0 is the value of this log. Okay, so, and that's what's happening. So 6 to the 0 power is 1, so the value of that is 0. Alright, pull that back to the front of your brain. In the meantime, so we have minus 2 times log base 6 of 10, which we know is 1.285. Negative 2 times 1.285 is negative 2.57. Alright, of course the 0, you can just erase it. So that is the answer for number 8. Wait, I guess I mentioned there's another way to do it. So I probably would have done this. Log base 6, you know this is 1 over 10 squared, right? Alright, so this would be the same thing as log base 6 of 10 to the negative 2 power. And then I would put the negative 2 in front, like you do. So that would have been log base 6 of 10 times negative 2. Okay, and then that would get you to the same place as this. But I'm very comfortable with negative exponents, so I would do it this way. People that are freaked out by negative exponents and keep forgetting what it really means, you'd probably like the red way better. So to each her own. Okay, so this guy over here. Let's see, what are we supposed to get again? Whoa, 4s and 10s? Okay, well there's a 10. This needs to be 4. Oh yeah, 16 is 4 squared. So this is looking very promising. Let's go ahead and do the quotient property and write a log minus a log. So this would be the same thing as log base 6 of 16, which is 4 squared, minus log base 6 of 10. Of course, using the power property, I can put this 2 in the front. So this becomes 2 times log base 6 of 4 minus log base 6 of 10. And of course we know what these are. These are the facts that we're given. So log base 6 of 4 is 0.774. And log base 6 of 10 is 1.285. 2 times 0.774 is 1.548 minus 1.285, no rounding, so minus 1.285, and that gives me 0.263. Kabam! That's number 9. Alright, how about number 10? Alright, so we're done with that part up there. Alright, with the making the 4s and 10s. So this is more about the table and things like that. So no calculator at all, but we do have our handy dandy chart. 625. Let's see if that's on the table. Oh yeah, 625. That is 4. That is 5 to the 4th power. Okay, so that means this is the same thing as log base 5 of 5 to the 4th power. Now, when you have the bases are the same, like log base and exponential base, these are inverses, so they are going to undo each other, and I'm just going to have 4 for the answer. Okay, yeah, about that. And again, this one, I would use negative exponents because I'm real comfortable with that. I'm going to show it that way this time. 64, use the chart if you have to, but 64 is 4 to the 3rd power. Okay, so I'm looking at this and I'm seeing
well, this is log base 4 of 1 over 4 to the third power. And I would use a negative exponent here. So I'm very comfortable that this is log base 4 of 4 to the negative 3 power. Alright, negative 3 drops you down. So you can write it this way. And then I can see I have a log base 4 and base 4, so that's just going to give me negative 3 as a result. I think that's the most direct way to do this problem. But here's another way. You could use the quotient rule, the quotient property. So you could write log base 4 of 1 minus log base 4 of 4 to the third power, 64, of course, being 4 to the third power. Log base 4 of 1 is 0. 4 to the 0 power is 1. That's how you do a log. And then, like we've done before, log base 4 and base 4 will cancel each other out and just leave 3. So we have 0 minus 3, which of course is negative 3. So you choose which one of these ways you're more comfortable with and own it. Okay. 100,000. This is clearly 10 to a power. What power? Well, let's count the zeros. 1, 2, 3, 4, 5. This is the same thing as log of 10 to the 5th power. Don't believe me? Do you believe a chart? Let's see. There's our 100,000. Oh, look, 5th power. Learn the rule about counting the zeros. Yeah, so there's an invisible base 10 here, don't you know? So this is an invisible log base 10 of 10 to the 5th power. And once again, if you have a log base and an exponent base, they undo each other. They're inverses. They cancel each other out. That's why the final answer is just the 5. Okay, brilliant. You don't have a pencil in your hand, do you? Alright, please no pencils, guys. Do this. Watch me learn how to do it. Watch like 3 problems and then go back and do those 3 problems yourself. Let's see. So, okay, there's a bunch of different ways to do this. Here's the way I taught you the first time around. When you have 1 over something, one way to do it is to kind of cancel out that 1 and ask yourself, okay, 2 to what power gives me 16? Alright, because that's how we normally do a log problem. Well, that would be 2 to the 4th power. Now, if you don't know that, use your chart. 2 to the 4th power is 16. Okay, so that would be 4. But because it's 1 over 2, alright, to drop us down to denominators, we need negative exponents. Okay, so the negative 4th power will make this happen. So that's probably the quickest way to do it. Now here's another way you could have done it. You could have done it the long way, which is to literally go, the question that a log asks is you take that base, like 1/2 to the what power is equal to 16. We could work from this equation and figure it out from here. Now, this 1/2 is like having 2 to the negative 1 power, right? And then you've got your x. And this 16 is 2 to the 4th power. So now that we have these both with a base 2, that means these exponents must be the same. So negative x must equal 4. Okay, so you can make that little equation, alright, by logic. Negative 1x equals 4. Therefore, dividing both sides by negative 1, I get x equals negative 4. Yeah, so that's the answer. Okay, clearly it was much faster to do what I did the first time. but whatever helps you do it. Similarly here, when I taught you this the first time, here's what I said to you. I said, look guys, a big number is becoming a small number, right? We're asking ourselves 216 to the what power is going to give us 6. Well, the only kind of power that's going to change a big number into a smaller number is a fraction, okay? Because what we really need is some type of a root. Okay, so it's really like this is what I'm saying. We have 216 becoming a 6. The question is, will it be square root or third root or fourth root or what? What type of a root changes 216 into a 6? Well, we can find that on the chart. Okay, it has to turn into a 6, so we know we're looking at this row. Alright, there's our 216. So look, it'll be the third root, right? Working backwards is always doing the root. So the third root of 216 would equal 6. Okay, so that means what I'm looking at is the third root of 216 will equal 6. Alright, well guess what? Third root is the same thing as the 1/3 power. You just have to memorize that. Alright, just the way it's defined. So that gives us the answer to this question. So the x here is 1/3. Alright, 216 to the 1/3 power, because that would be the third root. Alright, so all of this should be kind of in your head. This is not, they're really, if you do it right, there's no real work to show. I mean, feel free. But anyway, that's the short way to do it. Alright, of course you have to understand about the roots and stuff. Here's the other way. I still would have to start from here, so I'm still thinking 216 to the what power is equal to 6. And then if I look at the chart and I see that 216 is 6 to the third power, then I can go, okay, so this is 6 to the third power, and I've got that x, so that's 6 to the 3x power is equal to 6. And then this is like 6 to the 1 power, so that means 3x must equal 1. Alright, by logic, this must equal this. Okay, so 3x must equal 1. Alright, dividing both sides by 3, and you get your 1/3. Alright, now Mr. Burton, you're confusing me. Why are you showing me two different ways? My head is all a jumble. Can't you just show me one way and just keep it simple? Well, guys, I feel your pain. But the reality is, in that explanation just then, some of you are looking at the red version and going, obviously, well, that's the easiest way to do it. I'm going to do it that way. And some of you are looking at the blue version and you're going, clearly, that's the easiest way, so I'm going to do it that way. So as a teacher, I cannot decide for you which one of these ways is easiest for you. So I have to show you both so you can decide which way you want to go and then go with that. Plus, showing you all of this and the connections between math, that's kind of my job, showing you all these connections and how it all works together. So, sorry, that's why I do it that way. I'm trying to be helpful, not hurtful, but it just doesn't always work out that way. Okay, last one. Oh, by the way, on the, I'm hoping I get a few people to participate in this. I'm suddenly curious. How many of you like the red way and how many of you like the blue way better? So I'm going to throw up a poll on Edmodo where I'm asking you the question, on number 14, do you prefer the red way or the blue way? And so please vote. Vote on the poll and tell me which way you like better. Okay, number 15. We have 0.04. Hopefully in elementary school they taught you that this is the 10th place and this is the 100th place. Okay, so that makes this 4/100ths. So I'm going to write it like that. So this is log base 5 of 4/100ths. Best to reduce this fraction, right? Smaller numbers makes your life easier. So this would reduce down to 1/25. All right. I hope you see that I'm simply dividing by 4 in the top and bottom. Okay, so as far as evaluating this, I'm going to show you 2 ways to think about this. What I taught you the first time through was you could, remember when you have 1 over something, kind of scribble out the 1 and then ask yourself the log question. 5 to the what power gives you 25? Clearly the answer to that question is 2. 5 squared is 25. So the answer so far is 2. But then we uncover it, and because it's really 1/25, that means it will be a -2, because a negative power will drop you down to the denominator, which is what we have. So the answer is -2. Okay, so that was one way to do it. Here's the other way. Alright, if I have log base 5 of 1/25, I'm going to go ahead and write that 25 as 5 squared. And then this would be the same thing as log base 5 of 5 to the -2 power. Alright, since a negative power drops you down, these should be the same. And then log base 5 and a base 5, they cancel out, and you get -2. Okay, so that's another way to think about it. You choose. Alright, anyway, I do believe that is the last problem on this lesson. So I will see you on the next video. Keep doing your homework Burton style.